I have a 4-part session on Unity development coming out in MSTN Magazine. Actually, the second one on 2D just ran. 3D's coming out soon. And then we have the 4th one on building for Windows coming out next month. So that's enough about me. You are new to this, so welcome for your first session here. Excited to have you. Tell us about yourself.
This is my first MVA session ever. I'm David Crook. I'm a technical evangelist for Microsoft based out of Raleigh, North Carolina. Focus on gaming, cloud, development operations. I'm an ALM ranger and did a lot of development operations consulting at various Fortune 100 companies before being a evangelist with the Microsoft Consulting Services. You can reach me at the indiedevspot.com or also on Twitter at DavidCrook1988.
Very cool. Welcome to Module 4, 3D game development. I'm excited. Are you excited?
I'm really excited. 3D game development is one of my personal favorites.
It's where the scenes come alive, right? What we're going to be talking about today in this module is 3D in Unity, of course. This is the module on 3D. Physics, vectors in Unity, a reading input, creating ZombiePumpkinSlayer. So we'll kind of take some basic samples, piece them together, and you can understand how the actual final game was created there. It's still actually a work in progress. We are going to upload these assets to GitHub, and we'll have the assets available through GitHub, and we'll post those links out to our websites the next couple days. So you can see how everything was done. 3D in Unity. 3D.
It's awesome.
3D is simply X, Y, and Z. 3 coordinates. Unity actually has a left-handed coordinate system, so if you hold up your left hand, you can see we've got Y, X, or I should say X, Y, and Z is depth. In other words, into the screen, back out of the screen, that's Z. Very easy. If we remember high school math, you typically worked in 2 dimensions with a little graphs there. You had X and Y, and now with games and 3D stuff and really fast engines, we now have Z that we worry about. I don't want to say worry about, that we have to our advantage now.
I kind of like to think of 3D more like 2D top-down, just with the little extra component coming up.
Another way, too. Some of my favorite games, like the Command & Conquer series, like Red Alert, and good times.
Love it.
Let's start talking first about physics in Unity. The 2 main components dealing with physics in Unity, rigid bodies and colliders. You don't have physics in Unity without those 2 components. And as we talked in the first session of the day, they are just simply components added to the game objects. Rigid body and collider. A rigid body is what gives your object mass. Without it, your object doesn't have mass. Gravity must have a rigid body. Your object will not fall if you don't have a rigid body component on there. So mass and gravity. You don't have to have a collider on it, which brings us to next, what is a collider? If you want your object to recognize collisions with something else, you have one cube going to another cube, there has to be a collider. So without a collider, your objects will just fall through each other. They will understand gravity, but they're just going to pass right through each other because Unity doesn't know how to calculate that. So 2 main things required. Rigid bodies and colliders.
So what if I want to have a game with 2D and 3D components? Can I have the 3D colliders on my 2D or vice versa?
The 2.5D game?
Something along those lines, I suppose. Yeah, sometimes I see those games where you've got the 2D platformers and the 3D models, or 3D models and 2D.
You can mix up colliders. There are specially built colliders in Unity optimized for specific purposes, though. So if I'm doing a 2D sprite in Unity, I want to use the 2D colliders. I think you can actually shoehorn the 3D ones on top of it and vice versa. But typically, if you're on 2D, you use the 2D versions of colliders, and if you're doing 3D, you use the 3D versions of colliders. And we'll look at what those components look like inside of Unity. So let's get to a demo here with some physics and go over to Unity. For this one, I will create a new scene. And this is going to be similar to what we saw in the first session here, but we're going to add a couple more details onto this. I just created a terrain that has a built-in collider. It's something that we can work with. In fact, if we want to make it look a little bit better, I can just add a texture that's already in this project. And I believe that I saw.
So this terrain tool, it comes built in to Unity, doesn't it?
The terrain tool is built into Unity. Last year, for the Microsoft Virtual Academy session, I did a whole section on using the terrain tools here to basically sculpt out your environment where you can just raise, do everything that you want on here.
Oh, cool. We can even add little stars. This is great.
Stars, which is a good mountain shape on here. But let's use this little world to kind of talk about some basic concepts. If my mouse will actually click and let me move over here. There we go. All right, let's take a couple cubes on here. First, let's zoom in a little bit more. All right, so let's take some cubes. And got 2 cubes here. Unity has dropped them right there, which that will work. As it stands now, if I play this game, my camera's probably looking somewhere else. In fact, I can see my camera's looking over here. That's okay. We're going to switch back to this view. I'm playing my game. I'm going to switch back to my scene. My game's running. Notice, I have a floating cube right now. Crazy, huh?
Yeah. Who would have thought you could have a floating cube in a world?
So Unity, this is simply a mesh with a texture on it. It's just floating in the sky, or shader on it, I should say. 2 of them, actually. If we want physics to happen in this scene, what are the 2 things I said are required?
I think it was colliders and rigid bodies. Yeah.
So let's go ahead. Let's move this over a little bit. Oops.
So what happens if I leave one of those guys off?
We'll show you. We being me in this case.
Yeah, I don't have anything up on my box.
So in this one here, I'm going to do a rigid body. And in this one here, we're going to add a collider. And to your question earlier, what about the different types of colliders? If we look at under physics and physics 2D, under physics, when we add a component, we have all the various 3D colliders. These are the ones that originally existed inside of Unity. And you generally use these based on whatever objects you're using. If I'm using a cube, I want a box collider. If I'm using some sort of humanoid or zombie, I want a capsule collider. So you try to choose one that matches. There are other ones like mesh collider, which will wrap the entire shape of your mesh. Very, very exact for physics. Very, very expensive for computation time.
So I can use a couple of sphere colliders maybe if I got something that's double sphered.
Yes. And let's say you have a big
dinosaur.
Monster boss. Dinosaur.
Yeah, dinosaurs
For monster
are great.
boss in a game, you can take different colliders down the legs and arms, and you can use multiple colliders to kind of flesh out the collision zones on that character. So on this one here, let's do a box collider, and this one we have a rigid body on the other one. So I'm going to click play and come back to my scene, and you notice what happened here. This guy.
It looks like it fell.
It fell.
And
Actually,
it looks like it's rotating and hitting stuff.
I made a minor. Let me double check something here because I think I made a minor boo-boo. I added a double collider here. The cubes by default actually have a collider on them already. I added 2 on there, not a huge deal, but that's why it was actually bouncing as it went down. If I remove that, so this is my rigid body, I'm going to remove that collider. Let's just get rid of it. Remove
Yeah,
component.
completely. I love enabling and disabling the parts, though. It's fantastic.
And
Holy cow, it went through the floor.
right through there.
I'm going to file a bug against you.
That's a common beginner mistake, too, because either your objects don't have a collider, or let's add a collider back onto this. Add a box collider onto it. But I'm partially through my terrain. If you're already touching in the kind of the collision matrix, like let's do, hold on, this is going to be problematic here because of my...
The collision system's a bit faster than your mouse,
It is faster than me here. Let's try this guy here. See, it's acting funny now. It's popping up. Anyway, so one of the common things that you'll find, you place like a character controller, which we'll talk about shortly, objects on here, and they pass right through. That's typically because the collision zone is sitting just a little bit beneath the surface here. This is probably happening because of my raised terrain here. So I just want you to understand the basic components here. Rigid body gives your object mass, and you can actually assign a greater mass here to your object. This helps when one object is hitting another object. Who's going to win? Who's got the greater mass? That's what that affects.
Elephant versus the balloon.
That's right. Use gravity is checked off by default here. And you have other kind of more advanced options, like to be able to tell Unity, hey, don't rotate my object when it falls. I want to keep that rotation. And that comes in handy quite a few times. We'll look at that when we look at the game further. So what I did here was just a rigid body and a collider. Now let's take this a little bit further here and talk about vectors.
All right.
Like I said to Matt on the last session, Vector from Despicable Me. Did you see that movie?
I saw one of the Despicable Me's, but I was more enticed with the Minions.
Minions, love those guys. Vectors, they're just values. They sound confusing, and in math, they could be confusing. In Unity, They can actually take the place of a bunch of different things. They can be used to represent a rotation. They can be used to represent a direction. But in a nutshell, a vector is nothing more than a point, just two values. It's called x and y, but actually two values that by themselves have no meaning whatsoever. If you create a new vector, it's nothing more than essentially 2 points stored in an object. There's nothing special about it. A vector 3D object, which exists in Unity, just contains three values, x, y, and z. And again, they're just numbers. The fact that it's called x, y, z means absolutely nothing. They could have called it q, h, and a. It's just they try to map it to what you're using as your coordinate system in Unity. Vectors can represent different things, directions, values, forces. They can represent a rotational value. They're just values. And they can be relative too, which is something very important to understand in Unity. There's forward space, which if you were to hold up your left hand and we had x and y and z was depth. When you open your scene, you have these world coordinates. They're global. Forward is essentially z everywhere. Take a cube. Forward could be however that object is rotating. And you have the option of choosing one or the other in Unity. You can say, hey, in my world, I want to go z. Or I want to go z wherever my object is facing, which is actually forward. And so we'll look at a little brief example of that. Related to vectors, though, typically in Unity, you'll see in moving objects. And there's a bunch of different ways to move objects. In my MSDN series this month, I had, I think, 7 or 8 different methods listed of moving an object inside of Unity. And there's questions like, well, which one do I use? And the answer is it kind of depends. Typically, you add a rigid body to an object, and you move that rigid body by setting its velocity. So the first code example here shows we're setting rigid body velocity to, what did I say a vector was? Just hold some values, right?
Yep.
So here we're saying 7 in the x, 0 in the y, and 0 in the z. In other words, move at 7 meters per second in x. Now, in the next one here, we're saying, same thing. We're setting the velocity on an object, but this one looks a little bit different. Sounds a little bit more complicated. The top one goes in the world coordinates. So the top one where it says vector 7, 0, 0, that is in my global world space, how that object's moving. In the example at the bottom, we're setting the velocity to transform direction. And that basically makes it local. So wherever that object is rotated, it's going to move forward in that direction. So one way of dealing with world, one way of dealing with local. And they both come into play in different cases.
Yeah, that's a pretty cool trick. I hadn't actually been using that. I'd been doing all of my stuff off of trying to translate it myself. So cool little tip, even for me. So
let's look at some essentials in Unity here. The way I want to kind of structure this, since we're going to look at a more advanced but still kind of basic game that we pieced together, the ZombiePumpkinSlayers. What we're going to do is talk about the basic components required for that. So input, movement, vectors, and collision. So let's go ahead and look at that demo. And I have another scene set up here called Cube Me. We don't need to save this one. So what is in this scene? I have a terrain, which I created in the last one, which is simply create a 3D object terrain. Gives us just some base to work on. I have, it looks like it's kind of a little bit textured here. This is just a rock texture. This is actually a completely flat surface. Even though it might look like it's not flat, it's completely flat. I have a few awesome cubes. And what I've done with these cubes is they have a box collider, which is there by default. I've added a rigid body to each of these cubes. And in the first session, I mentioned tag. It was simply a way to assign a text string to an object here. I tagged them as enemy cube. And we'll see why we do that in a second here. And then I have a cube with controller. So this is the special guy right here. This cube has its own component on there, a script. Let's look at what that script does. We have two code methods we're going to use here. We have update. Let's increase this font size just a little bit.
There we go.
So we have update. Now, in Unity, when you want to read input, there's an input system in Unity. So if you want to read however you're moving horizontally or vertically, you call input.getAccess with this name. And what does that name map to? So if it's using a string here, horizontal, well, if we look over in Unity, under our project settings, input. And there's a bunch of preset definitions here. Horizontal The name horizontal means we're looking at the left and right arrow, or the A and the D key. Think of the common keyboard gaming keys. A and D move you left and right.
So why do I want to go through this instead of using the get key, input.get key code?
I like using an axis because axis you can map around. It's easy for me conceptually to represent horizontal and vertical. And then I have a whole input manager. I can easily swap them out and change them, or if I want to assign to a joystick.
So if I want to configure my own keys, it makes it a little easier?
Yep, absolutely. You can just set them right in here. You've got your own custom key definitions. So I'm just going to read horizontal here. And this is going to be a value between -1 and +1. And when you hold the keys down, Unity will actually scale that object, those values, and it kind of ramps it up pretty quickly. You can control how quick it ramps that value up. Let's just see what those values look like here. Let's run this. And I'm going to view my output here. Right now it's 0. I'm not moving anything. Let me find that cube. Oh, you know what I did? I turned off my camera. Turn that guy back on. All right, so I've got this cube right there. Input is currently 0. Now notice, as I press the D key or the right arrow, either one, I can see that cube kind of pressing over a little bit. And these input values, they scale up and scale back down again. Unity's actually collapsing these debug messages here. There we go, 0. So that's how we read our input. Now we can take that and we can map that to something. So we've got some value between -1 and 1. We can say, you know what, we want to move in our Z direction by some value. In other words, whatever we're reading from our input. So we press the keys, we get this horizontal value. It's a pretty small value, so we're just going to multiply it by some sort of speed. In this case, I use 10. It's an arbitrary number. You kind of find what works for your game. And that becomes our movement vector. Again, it's just a value. It's 0, 0, and yet 0 for x, 0 for y, and in z we have some value. And we're going to set our rigid body's velocity to move in that direction. So that takes care of moving over. Next, because we have a collider on this object, we can actually hook this method here, which is behind the scenes. Unity uses reflection to see if you have these methods defined in your class. And it calls onCollisionEnter and passes you this collision object, which is based off of whatever you've collided with. So I'm doing a little debug log, this.name collided with whatever I've just collided with. Now, I said I was using a tag. And why am I using a tag? Because you can collide with tons of things in your game. Your cube can drop and collide with your terrain. It could collide with another cube. It could collide with all sorts of things. I only want to do something when I hit an enemy cube.
This kind of goes back to an earlier session when we were talking about prefabs, because the name, if we went off that, is possibly a clone, right? So if they're all tagged the same.
Yes. So in other words, I could say if collision.gameObject.name, but that name can change. To David's point, if I'm using other prefabs, we looked at prefabs in the first session, and I create one dynamically, which we use the instantiate call to do that with. If I create one dynamically, its name can change. It could have a parenthesis clone after its name. So we look for things by tag. And so I've tagged those cubes as enemy cube. If it's an enemy cube that my main cube collides with, I'm going to just destroy that enemy cube. Now, we're not destroying our collision object. Collision is a component. We have to pop up one level and destroy the root game object. This is something you'll see all the time. Since the game object is your root object, that's really what you want to destroy, and thereby destroying everything underneath it. So let's see what this looks like. We're going to run this guy. Move over to the side here, and that cube disappears.
You got that cube.
I got that cube. Got that cube? Oh yeah, I'm on a roll. I got 3 cubes. I'm cubed. Yes. So now what do we want to do next? Notice I've got a little text here, increment score.
Oh, there we go. Yeah, you always have to have scores in games.
So we can easily create an integer value called score. And next, we're going to want to create some reference to text on the screen. Let me delete what I have here so I can show you from scratch. This is Unity 4.6 beta right now, hopefully to be released shortly. You can get this beta on their website. Everything I'm showing you today can be done with the free version. And I'm going to create, under the UI menu, text.
Ooh, this is that long-awaited UI that everyone's looking for.
Initially called UGUI, now called UI, and so we'll see if that's the final name, but UI is what it looks like it's going to be. People waited a long time for this because the old system was kind of painful to use. Now you can drag and drop objects. It's so much nicer. So I'm going to create some text here. And you can see it creates this canvas element here. If I double click on it, there it is. Now let's take this text. I'm going to go into my 2x3 mode here because it makes this a little bit easier to see.
So you have to essentially drag that text within the bounds of that white square to make sure it's on the screen. Is that what I'm gathering?
We can see it over there on the side. So this represents my screen. And this can actually see how it grows and sizes. That canvas dynamically changes to whatever size, essentially, device that you're on. So what I'm going to do here is I've got a couple fonts in my project. And you can just go over to, we were talking about earlier, something like thefont.com. Find a free font there, download it. I'm using one that Matt put into this project here, Ghoulish. Let's bump this size up a little bit. Now, I can type in a new size, or it's a little discoverability thing in Unity where any number, you can actually click on the name and it becomes a slider.
There we go. I like the Ghoulish.
We'll call this score 0. All right. Now I need some way to update this score when I do something. So let's go back to my code. And in my code here, I've got a score. Let's get a reference to that text box. And I can create it private, because I might not want it exposed to the world. And this is a text element, which by default is actually not there. You have to bring in, by default, it's not going to be found. So if I right-click on it, I can just resolve the reference. It exists in this namespace, unityengine.ui.
It's one of the nice things about using Visual Studio.
I love it. So we have this element right here. Now, this is just a private variable. How do we set it? Well, we can search for it when this game object starts up. But I'm going to use one of my favorite features of Unity, and I'm going to display this field in the editor. If I make it public, it will automatically show up in the editor. But then it's public that other classes can read that value. I don't want that. I want this still private, but I want to expose it in the editor. So I'm going to add the serialized field attribute to it. And simply by doing that, if I go back to Unity, and I look at my cube with controller, what we'll find here, notice,
there it is.
I've got that text box there. It's not assigned, so I will just drag this on over. Voila. It's assigned. And now in my code, after I do my collision and destroy, I can say, hey, I want to update my text. It's a text box with a text property to. Now you could use string.format here, which I would typically do, but just to save a second or two here, I'm just going to say underscore score dot to string. Alrighty, let's see what happens, shall we?
I'm excited. I'm hoping we get 3 points.
All right, now let's try moving this over. Oh, you know what I forgot to do?
What's that?
Increment my score. Score plus plus.
You even had your comment in there for it, too.
Increment score. That meant the overall process, which the UI is so essential. But so is the others, right?
Yeah, you can't forget to increment the score, yeah.
All right, so let's move this guy over here. 1, 2, 3. Easy enough. These exact same concepts we just did right here, where we read input, move an object. Typically, you'll actually see this done in fixed update.
Why are we doing it in fixed update?
So, update calls per frame. If your game's running 40 frames a second, that's running 40. This code is getting called 40 times a second. With fixed update, the physics engine in Unity works at a fixed time step, which you can define in Unity. I think it's 0.02 of a second, so 50 times a second it runs. And because physics, they need a consistent value to do it in. So this method gets called basically 50 times a second. It's a fixed time, and that's good for physics. There's rules sometimes we can use one or the other. I cover that a little bit more in the MSDN magazine article because sometimes you want linear motion, sometimes you want scaling motion, so one's good for one, one's good for the other. But typically, anytime you move a rigid body, I should say often, you'll see in fixed update.
Makes a lot more sense now.
So now, these same concepts here, colliding with an object and moving an object and updating the UI, they are essential concepts, which will bring us to, when we create our game, piecing all the elements together. But first, people are going to notice when I run this game, they're going to say, all right, this is a 2.5D game. We're talking about 3D here. How do I run around in a 3D world? And I just want to show this real fast because it's so essential to understand the options that are out there. So that's going to bring me to something called character controllers. And if I go to my Unity project, the same one I was just using, I'm going to disable that camera. And I have brought in Unity's sample assets, it's called. Right here. In the asset store, you can download sample assets. And there's an AI character, AI car. They've got this little first-person and third-person controller. So I just imported that into my project. Once I did that, I can come over here under Standard Assets. I'm sorry, under Sample Assets, Characters. Now, I could do a first-person controller, and I could just simply, let me find one of my cubes so I can place this right near my cube. I can drag and drop this guy right here, run my game.
Oh, we have a game.
And I have footsteps. I don't know if you can hear those or not. I can jump. So I can do that with a first-person controller. I can delete my first-person controller. I could come in here with a third-person controller. And I could run around with that third-person controller as well.
And these assets are really great just to bring in and take a look at to see how they're actually building these assets.
Now you'll notice the funny thing is I'm reading input on the cube, and my characters are reading all of my full input. That's why you see both of them running around. And look at that guy runs into the cube, knocks him around. So really, really cool things you can do easily. Since you want to get up and running in a game fast, I highly recommend downloading those asset packs and checking it out. For what we did in this next game, ZombiePumpkinSlayers, we kind of wrote our own code on there using the exact same principles that I just showed in that demo scene there. Exact same principles. So first, let's cover what we did on the title screen here. So our title screen that we did, let's run the game here so you can see it. You guys are going to see the game now. At least we'll see the title screen first. We'll slowly unveil it.
It's always the best way. You can't give away everything right away.
Give away everything. You got it.
It's kind of my favorite music track, too.
I love the feel of this music for this game. It's just
Zombie
right.
Surfer dude.
ZombiePumpkinSlayer. We've got this animation going on here. Got some UI elements here. When I click on this button, my scene will load. So before we do that, though, let's just kind of do a walkthrough here. This is nothing more than some UI elements placed out here. Let's go like this to unveil what this really is. Remember, on that last level, when I added a text box, it added a canvas element for me. That's what this new UI system does. Any UI elements add this canvas here. So what's a UI element? If you take an image and drag it on your screen for what Carl was doing, for example, that's a sprite running around on the screen. That's not a UI element, typically, although it can be. When I think of a UI element, think of a heads-up display in a game. You know, you've got a score in the upper left-hand corner, and it shows you your power-ups in the lower right-hand corner. That's, to me, that's a UI, a GUI system. They're fixed on the screen, although they don't have to be. With a new UI system in Unity, they can follow characters around. You can actually have any UI object anywhere in your scene. But for the sake of this, for what I'm doing here on the title screen and for the score and whatnot in the game, I'm using the UI system. And anytime you add any UI component, it creates the canvas for you. And this event system, which is how it detects what you're clicking on. So under the UI menu, you've got a couple basic things. You have a panel, which is nothing more than an image. You have a button, which is nothing more than an image with text and a script on it. You have text. You have another image. So a lot of these are based off of images. And literally everything I have here, except for nothing, actually, except for this button here. So I've got these images right here. Let's see each one. So I've got my background. Let's zoom in on this guy a little. You can see that bluish image in the background I disable. That's nothing more than an image right here. And early on I talked about a game object being this name and tag and a transform. With the new UI system, you have a rect transform, which is a different object. Similar to the regular transform, but this is fixed more for 2D. You have a whole anchoring system on here that you can anchor things in the corners so they will stretch with the screen. Very similar to what you'll find in Visual Studio for when the new .NET stuff came out and the new Windows Forms and XAML, how you can take elements and dock them in there. Very, very similar to that.
So I can dock elements inside of other elements as well then?
Dock other elements inside of elements, inside of other elements, inside of other elements, make them all scale out in front of each other, do some really cool things there. So these are nothing more than images with a script on here, which basically just says, hey, what source image is this? And it's just a sprite in our scene. When Carl was doing the character animations, they were just sprites. These are just sprites assigned to this script. Same thing all down the line here. We've got Pumpkin Row right there, those pumpkins. We've got the Blue Glow, just nothing more than a glow. Blue Glow. Pumpkin Row.
That sounds like a band.
I know, I was thinking
Pumpkin Row.
Now you've got Skid Row stuck in my head. We got the logo, ZombiePumpkinSlayer. Notice here, we can set, if we want to stretch, see how it's stretching with it and it's growing?
Oh, that's beautiful,
because
too.
I've set that in the horizontal direction. I want to expand. I can expand in horizontally and vertically if I want as well. So and down here is a button, which is nothing more than an image and a script on there. With these scripts, it can detect a click and call new a method. There's a couple different ways of doing this in the UI system. And also, you can have different transitions. So when you mouse over your button, you can play different animation. These are just 2D animations, just like Carl showed in the 2D session. And they will create these for you. When you basically create a new button, let's just create a new one to see this here. UI button. If I go to animation,
look at that.
Auto-generate animations. If I click on that, it says, hey, what animation names do you want this? And it'll create them all for you. So it's real easy to do. And a button, again, is nothing more than an image with a button script and a text component underneath. So real basic components that make up this UI system to do some powerful stuff on there. Now, when you click on the button, again, there's a couple different ways to do this. In my button script, I'm saying, this game object, I want you to send a message to it. Send a message. And again, there's several ways to do this. I can think of actually 3 off the top of my head. A direct reference. You can hook into this event in code. Actually 4. You can use your event system, or you can specify a method here. So this send message function says, give me the text of a function name on this component. So it exists in code somewhere on here. Let's open the code. This function is what I'm going to call when you click on the button. So let's go back to that. This here is going to call the play click button, the play clicked method, I should say. And in order to load a new level, in other words, load a new scene, they should probably call this load scene. It would make more sense to somebody first learning this. You give it the name of your scene. Now that scene has to exist in your build. File, build settings.
With a check mark next to it.
Yes, file, build settings. This is where all the goodness happens. This is where you can select all your platforms. It's also Control-Shift-B if you like hotkeys. It's the same hotkeys Visual Studio. And in here, you can say, I want this platform, set that as my default. These are all the scenes here. You don't have to have them all in here.
Ooh.
You can kind of keep them all pretty simple if you want. Let's do this here. Remove a bunch of these. And actually, just to show you this is how the empty dialog box is right here to start. I can add on the current scene. We've got that one, okay. Now I've got the title scene in my build. Any other scenes I want, I can just take those scenes, maybe drag them into here. And that's
Pretty
it. So
cool little shortcut there.
These are the names of the scenes that must exist in order to call that code. So I need a title or arena, Adam main. Now let's run this guy. So we have our title screen. When the game runs, we'll click on that. It calls application load level. Now we get to unveil. What do we get to unveil?
The actual game itself. You guys ready for
ZombiePumpkinSlayers? All right, let's look at this. Now, let's kind of dissect all this out here. Before I do that, let's make sure we get the right slide here talking about this, because this is of epic proportions. We don't want to miss this. Demo, creating ZombiePumpkinSlayers. This is going to be the gameplay aspect of it. This is going to model all of the basic components that we just looked at with those cubes. It might look complex-ish. Let's run this and see what happens. Actually, let's make this bigger when we run this. So you can click maximize on play. Let's run that. So we created this over actually the last few days. We had a bunch of different ideas. So these guys come up to the tombstone here, and they try to attack it. There's some particle coming out of that tombstone. There's randomly spawning pumpkins here. They're playing different animations. And your job is just to keep smacking the heck out of these pumpkins that are here. Let me eliminate these real quick.
What an awesome set of graphics on
there
here as well. Talk about the power. Cool lighting effects.
So the Matt is I did all the code integration behind this. Matt is the mastermind behind, of course, all these graphics on here. So let's pick this apart here. Let's see what we've got in this scene. We've got more guys coming here. This is what I was talking about way, way earlier, though, so I can just show you while I'm here. We can do per frame advancing here. You can see my little guys running, each little frame there. So if you need to do fine-grained debugging, you can use that a lot. Okay, so let's pick this scene apart. We have a world that's a 3D model. Let's go in the wireframe here. You can see it's kind of it's a little bit dark in there, so we can see in the background here. If I go like that, actually, let's do textured wire. So we've got a level. You can buy these off the asset store. You can make them yourselves. We're going to talk about this a little bit in the optimization session tomorrow. We've got more 3D models that are just kind of plunked in here. If we look at this guy here, just a mesh render.
Pretty simple,
that shows it's very, very simple. Our pumpkins are just also meshes, and they have a little controller script. They have a rigid body on them, so they're on the ground, moving across the ground. They have a pumpkin controller. It's got a speed. And I simply have a variable defined here for hit colors. If you notice when I was hitting it with the hammer, it would flash a color. And when the pumpkin gets smashed, we play a particle system. Remember I showed earlier, real quick, I did a particle system. Look. So this particular particle system I used on here was part of the Tune FX pack, which is a really cool particle system on there. You can find some free ones and pay ones on the Unity Asset Store, some really neat ones. And I basically say, hey, I need a reference to a particle system I want to play here. When this pumpkin starts up here, we find a couple components. So this pumpkin has animations. We need a reference to our animator component. That's going to control what we're going to animate, what we're going to do. I need a reference to my renderer element. Well, what do we do with our renderer element? We're doing nothing more than flashing a red color. That's why we need this component. Now movement, I'm just a little caching a reference here. Sometimes we'll cover this in optimization section. It's best to cache certain things, saves on what's called garbage collection and allocating memory later on, sometimes if you do things up front. We'll talk about that again more in optimization section. I have a game controller object in my scene. Game controller is just essentially a near empty game object. It has no visual properties. And a game controller you find in a lot of games. It's a script, an object in your scene that has some code methods responsible for doing something. It's kind of like the coordinator in your game. In this game, this one is responsible for updating the UI for a score, exactly like we saw on their cube demo. And we have some random stuff, some random spawning.
It's kind of like the orchestrator.
The orchestrator, yes, exactly. Now our pumpkins, let's click on this pumpkin here. Matt designed this pumpkin, and with them we have in our enemies folder a bunch of pumpkin enemies. So we have a model for this pumpkin. Let's find, here we go. This is the model that Matt created for the pumpkin. And then separately are all these FBX files, all the animation data contained within them. Actually, in these cases, these are .ma. These are dropped in right from Maya, but they can also be FBX files. And in here, if I expand it, I can see I've got some sort of data in here, a bounce animation. It's going to be pretty tiny here. But you can tell something's bouncing up and down there. So the animation data is simply combined in these separate files here. So what we're doing with that animation data at runtime is we have an animator component. Let me shift spacebar here to make this bigger. And what the animator component does here is this simply will take a animation state. And let me get out of this again to show you what an animation state is. These are simply, these little cubes here, these rectangles, do nothing more, absolutely nothing more than point to an animation file. These are the files that your animator creates, or you get from the Unity Asset Store. You can get literally tens of thousands. I think Mixamo in their catalog has over 10,000 animations available.
Wow.
So these point simply to an animation file. If we click on one, we can see what it points to here. Bounce 1, bounce 2.
What's this system called, by the way?
This is Mechanim.
Mechanim, okay.
In Unity, you had several different animation systems. You had the legacy animation system and Mechanim, which introduced these ways of blending animations together and these state machines. Gives you a nice visual way to kind of see everything that's going on. So, for example, let's take our zombie kid.
Ooh.
So our zombie kid here, let's run this. And let me actually make this not maximize. And we've heard the soundtrack many, many times. So let's mute that.
Oh,
Sorry.
there goes our...
I know, it's cool. So Zombie Kid here, we get this auto live link, and we can see what's playing right now. Idle's playing. And in code, I can control it. I can say, as soon as I read input, transition to run. Well, how do I do that? I can set up little variables here. I can create a new variable. A Boolean variable called whatever I want. And I can control these in code through that animator component. So I could say, I want you to transition to get hit when I set hit equals to true. How do I know when hit equals true to transition over? I click on the arrow. And I'm saying right now the default is play animation, go right to this one. I don't want that. That's saying play the animation idle, and when you're done playing it, go to get hit. I want to actually trigger this only when hit is equal to true or false or whatever. As soon as that value becomes true, it switches. And you set those values in code. So if I go over to my project here, let's go back to our Pumpkin controller. Right here. So let's say, for example, this was the get hit. If I wanted to call that animation right here, that was the hit variable I added, the hit Boolean value. If I wanted to trigger that animation, all I would say is animator dot set bool and give it the name of it, hit, comma true. And that would actually transition that animation state. And you can mix them a bunch together. You can do some really, really cool things. As I mentioned early on, I think in the first session, that Mechanim allows you to have a character potentially shooting from the upper body and running with a lower body. And you can actually take multiple animation files and mix them all together. The sample assets have a great example of that. They use a whole bunch of different animations for running and turning to blend between all those
where you kind
states.
of tilt over to the side a little bit while
right.
making a right turn.
So we've got simply some code that's controlling the pumpkin state. And that code here, let's go back to this. Fixed update, the movement of the pumpkins, all we are doing. The pumpkin's entire existence says as soon as we come to existence, whenever this fixed update, remember that runs with the physics step, that happens 50 times a second. Whenever we call fixed update, we're setting the velocity of our pumpkin in some vector. The forward vector, and since we're using this transform direction, is the forward vector for our pumpkin, meaning wherever our pumpkin is rotated, we're moving them that way. So how does that come into play in this scene? I have two spawn points. They're just random. A spawn point is nothing more than an empty game object. That's all. It's an empty game object. There's no properties to it whatsoever. And I can simply, when I spawn something, just create it at that location. So I've got two spawn points here.
Spawn left and spawn right, I guess?
See them right across opposite sides of the tombstone there. Spawn right, spawn left. So all they do is an object gets created right here and just starts moving in its forward direction. I create an object here and I rotate it towards the cross and it just starts moving in the direction. All that is accomplished simply by one line of code. Set its velocity to move forward. That's it. Now, the main character, so that's the pumpkin. They're pretty dumb. I hate to even call it AI because it's really, 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 really basic. The main character, Zombie Kid here, notice when I highlight Zombie Kid, what do we see? On his little hammer there, I've got this big green box around it. That big green box just so happens to be...
It's a collider, isn't it? Ooh, he's far down that chain, too.
Yeah, and you'll see this a lot. When somebody gives you a 3D model, there are actually many levels nested deep of various bones, so to say, various aspects of this character. So if we look at Zombie Kid, we've got body, root, lower back, chest. You can work your way down. So right clavicle, right shoulder, right elbow, wrist. It comes like that. And typically when you get models and somebody gives it to you, they're already auto-generated like that outside of like Maya or whatever the tool is. You can control that in that particular tool, but you'll see this quite often. And so what I did was I just found the club in here, and all I did was I added a box collider to it right here.
So I could do the same thing and put one around his head for headshots.
You could put one around his head. Now the reason I added the box collider here, because I want to know when this hammer hits a pumpkin. So I added the box collider here, and my pumpkins, on the other hand, they have a sphere collider.
Ah.
So when this hits that, it triggers an event. Remember we saw the events before?
Well, it's kind of hard to read, too.
Code here.
Can we get it a little bigger?
Crank this code up a bit.
There we go. Now
Remember, anytime that we call collision events here on collision enter. Now there's actually, what I did in this case was very slightly different. And you might notice here that this checkbox is checked off on our collider. So a collider can serve two purposes. A collider can be for physical interactions. We saw when we took our cubes and ran them into each other that they literally pushed one out of the way. It had a velocity, hit the other one, and moved it. That's a collider. And a rigid body, because we have mass. You can also have a collider as what's called a trigger. And what you are telling Unity is do not do any physical interaction but notify me. In other words, when one object comes within range of another's collider, don't push it out of the way. Let it go through. But you notify me in code that something has happened.
You can start whole event sequences using this.
Exactly.
Conversations or...
Exactly. So in this case here, I don't want this pumpkin to get pushed out of the way. I want this really animation to go right through it. But I want to be notified that that trigger happened, and then I can decrement count and just destroy my pumpkin. To your point, what you said, you can spawn off conversations, right? If I have, let's say you could converse with a zombie sitting here. I could just take this guy and add on let's just do a sphere collider, just as an example here. Scale this out a ton and set it equal to a trigger. Unity will now notify my code event. I have to have, I'll show you this here.
One important thing to talk about is it's notifying the code event for that particular object.
For that particular object. And when you have a trigger, it's no longer on collision enter, it's on trigger enter. Very similar purpose. It's just one notifies you and there's a physical effect. One notifies you with no physical effect. So all I'm saying here, let's say your character comes in within this region. Bam, your zombie comes to life. Or you start conversing with it. That's how regions are detected inside of Unity and many other systems as well.
Now we can have him stop talking to me if I walk outside of that too.
Yeah, so there's three with a trigger. You have three events typically used in that case. You have what we're doing here, on trigger enter. You have on trigger stay, which fires near every frame that you're within here. So this on trigger enter gets fired once when you move into this range. As long as you're in that range, on trigger stay keeps getting, and then you'll get on trigger exit when you get on out of there. So three events that you can use for that to detect exactly what the state of that character is in there. We added score. So let's do this. This is on our player. This is on our zombie kid. As soon as that hammer hits something called a pumpkin, we're checking to see if we are currently using our smash animations. Why would we do that? I'll tell you why. If we're standing there not doing anything, and a pumpkin runs right into our hammer, do we want it to apply damage?
Yeah.
Kill all the pumpkins. We could do it that way. I wanted somebody to run around this game and always have to hit them as opposed to stand there and let pumpkins run into them and die. So I wanted to make sure I was playing a smash animation before I would dole out any damage. That's all this code does right here. If I happen to be playing a smash animation, then I would give me a reference to that pumpkin's controller, and I call a method on there called apply damage, which does nothing more than we basically had on our
So you could take these same concepts and apply them to other types of fighting games, per se.
Absolutely. This is exactly how it's done.
Perfect.
You call apply damage, it reduces the amount of your health. If your health gets less than or equal to 0, because maybe multiple things are hitting you at once, you always want to check if it's less than or equal to, then you start a coroutine. And this is kind of a weird-looking thing.
Die.
But so not only die is a weird-looking thing, but start coroutine. A lot of folks, if you're joining us today, happen to be a .NET developer or C or C++, whatever, and you're used to spawning off threads on a system, the question comes into play, how can I do threading inside of Unity? You don't spawn off threads in Unity. You start off coroutines. Unity works off a coroutine-based system. You can read about it on the net. It manages all of that for optimization's sake on the back end. So you basically tell Unity, I have the intent to start a routine. You give it the data, and it will schedule it in its preemptive system on the back end. And so that's start coroutine. So I'm essentially saying, do the equivalent of starting off some other processing thread here, but in Unity use coroutines, and I just call my die method. And die does
exactly like it sounds.
Exactly like it sounds here. I have some comments because we're going to build upon this more tomorrow. Die instantiates my particle system, and in this case, it actually deactivates the pumpkin, and we'll talk more on that tomorrow, why we would want to do that when we do our optimizations. And then we simply game controller increase score, and that's where we get our pumpkin count increasing on there. All the same concepts. So what we're doing here is we're using a rigid body to move our pumpkins. We are using a rigid body to move our player and our... I should have just overall bumped up the font size. Right here, we are doing the exact same thing on our player. We're reading the input from your keys and mapping that over to its vector. Same thing that we do with the cubes. And we have some other code in here. This guy right here.
This looks a lot like 2D, just with an extra Z, doesn't it?
All I'm doing right here, yes, exactly. So this is really a 2.5D game. It's a 3D world. But what I want to do here is I want that character to run back and forth. I don't want him to go anywhere else. So I'm really constraining him to some dimensions here. I also don't want him to run outside of the world. That's where you can use things like the math.clamp function. This code will all be available for download. I'll have some extra comments in here. The main thing is here, we're doing all the exact same stuff that we did with our cubes. We move an object, we detect a collision, we increment a score, and we destroy an object. And potentially when we destroy an object, we spawn off a particle system. It's really a really easy process. Everything else is on good graphics, good gameplay, tying that all together and making it something that kind of looks very interesting. So thankfully, the asset store, you can download a lot of cool stuff from there and use it, or hook up with an artist. Really cool ways to do that.
I gotta find me a Matt Newman.
Gotta find you, Matt Newman. Very, very talented fellow. So that is it for the magic of a 3D game. That brings us to the end of our 3D session today, and we're going to have about a 15-minute break this time before we continue on with the next session, and that's going to be building your games for Windows, and we will see you then. Thank you very much.
Sounds good. Thank you, everybody.